Audio Jungle. Audio Jungle.
RAMJET. Ideal RAMJET. Okay. So now that the word, first of all, you just focus on the word. What is the meaning of it? Why this engine is called as RAMJET? Earlier it was turbojet, turbofan. Why it is RAMJET? Okay. Turboprop you had seen, turboshaft you had seen. Okay, kind of engine. But why it is RAMJET? So first of all, what is the meaning of ideal? Ideal meaning is what? The process is what? Reversible process. Okay. If it is reversible process, and already you had considered, because system is what is the process happening, it is very fast, so it is adiabatic already. Okay, diabatic. So that combination is what? Very deadly combination for the reversible adiabatic. What is the reversible adiabatic? Reversible adiabatic. This process called as isentropic process. Isentropic process. And what is the mean of it? Entropy constant. Okay, this system, any process in which there is the reversible adiabatic. Reversible means, another word also you can say, reversible means what? It is frictionless. If any process is what? Frictionless, so it will be reversible process. Frictionless. Okay, frictionless process will be the reversible process. Frictionless process, please, reversible process. Okay, so an adiabatic process, I told you, it is very fast process. And if it is very fast, so definitely there is no heat exchange, I must say. Means no heat addition, no heat rejection, because process is very fast. Okay, so that combination, reversible adiabatic, I told you, it is very deadly combination, and the new name is what? Isentropic process. What do you mean by isentropic process? Isentropic process means entropy is what? Constant. Okay, number one. This is the mean of ideal, everybody knows, but I am recalling that. Okay, now coming to the RAMJET, like earlier you had seen turbojet, you had seen turbofan, you had seen turboprop, you have seen turboshaft. What is the common thing here? What is the common thing here? Turbo, turbo, turbo. Okay, now I am just going to tell RAMJET. Scramjet is what? Not in our syllabus, but I am just writing the name only. So in these two engines, we are not saying turbo word, we are not adding turbo word, but previously like turbojet, turbofan, turboprop, turboshaft, everywhere. So turbo meaning is what? Related to the turbo machinery. If I say turbo machine, that means it is not only turbine, It is turbine and compressor both. Okay, turbo machinery. Turbo machinery means turbine and compressor. All right. So if in any engine, turbine, compressor, these components are using, then the word turbo will come. And obviously I had explained that different types: turbojet, turbofan, turboprop, that what are the different working principle, working function. Okay, everything I had explained. So there you had seen, okay, turbine and compressor were there, hence the word came turbo. But in ramjet we are not using turbo word, so it is now very clear we are not having any turbo machinery component in ramjet. Okay, so how that engine will work, the question is how that engine is work. So for that purpose, ram word you can understand, ramjet. You can take separate part here, ramjet. Okay, ram plus jet. So one word came from here, it is called ram effect. Ram effect, what is the ram effect? In diffuser I had explained two types of efficiency in inlet or diffuser, you can say. That was ram efficiency and isentropic efficiency. What was the ram efficiency? If you remember, ram efficiency, it is indicates the pressure variation, and isentropic efficiency, it indicates temperature variation or temperature changes from inlet to outlet. What are the changes of the temperature? That measurement you can do, isentropic and actual temperature rise you can do with the help of isentropic efficiency in diffuser, if you remember. But the same way, because temperature, total temperature is what changing from inlet to outlet in diffuser, so definitely pressure will also change. So for the pressure variation, for the change of pressure, the measurement with the help of efficiency, and that efficiency called as a ram efficiency, if you remember. In diffuser I had explained well ram efficiency, and it indicates the pressure variation. So here in ramjet engine we do not have any turbo machine, we do not have any compressor, we do not have any turbine, only we have combustion chamber. Like in previous cases, combustion chamber was there. Here also we have combustion chamber, we have nozzle here, we have diffuser here. We do not have any rotatory part, because compressor and turbine are rotatory part, so we do not have any rotatory part in ramjet and scramjet. I am not going to explain scramjet, it is not in our syllabus, only ramjet I have to discuss here. So first thing very clear, in ramjet engine we do not have any rotatory part. Okay, okay, no rotatory component means not turbine or compressor. We do not have any rotatory component. So then how that pressure, because for the combustion, in combustion chamber, for the combustion of air and fuel mixtures, we required high pressure. So how the pressure will be raised, because we do not have any compressor here, that component we do not have. So how that pressure you can rise, I mean adequate pressure, how you can get in combustion chamber, so that you can have a ideal combustion in combustion chamber. How it is possible? So in that way you will have ram effect. Okay, so what is the ram effect? So basically ram effect is what, with the help of ram effect you can get the pressure rise in ramjet engine. That's the reason the name of the engine is what given, ramjet. ram effect actually, because this engine, I told you, this engine will not have a static thrust, that already I had explained. We do not have any static thrust in ramjet engine. So how it works, and I explained that time in my previous lecture. If you go and watch that previous videos, so you will get that ramjet engine aircraft will be launched, okay, will be launched at some altitude with some speed, because that static thrust for this engine will be zero. So for that reason you have to launch with some another helping component, which is another aircraft actually, and you will go at some altitude with some speed, you will launch it, and then it will work. Okay, point one point. Second point, now if you go for the working process, so how the pressure you can rise inside the ramjet engine. So for before going to that component of and all the numbering process here, I will tell you ram effect. So ram effect is what basically, whatever the pressure you are getting, definitely there is the conversion of energy. And what energy? Because it is having a very high speed, because I told you, I said it is launched with some another device. So definitely another aircraft will have a very high speed, and from there you will launch this ramjet engine aircraft. So where you are going to launch, suppose you just check, you just think, suppose this is the another five aircraft, you can say, okay, and now this is the fighter aircraft, or what you can say, you can, okay. Now if you are going to launch here, here we have a, suppose this ramjet engine uh, aircraft, okay. Basically it's a like a always used to, so this is the launching aircraft, this is used to launch this ramjet engine aircraft, okay. So this aircraft will have a suppose speed of v infinity. So this ramjet will also have some very high speed, you can say it is 800 kmph, just for example. So definitely this will also have a 800 kmph, yes or no? So basically at starting only this engine, during the launch only, it will have a 800 kilometer per hour speed, you can say. So now the kinetic energy of this aircraft will have a very high, very huge kinetic energy available for this, okay. So now this high kinetic energy will convert into pressure rise, convert into pressure energy. So that process called as ram effect. So that conversion of kinetic energy into pressure rise, okay, called as ram effect. So because of this effect only, the pressure will rise, okay, the pressure will rise, and that high pressure will be there in the combustion chamber. So the proper combustion may occur, and you will get jet velocity, and with the help of jet velocity you will have a thrust of that ramjet engine aircraft, and then it will fly, it will go and hit to the target. It is almost, sometimes missiles and rocket systems will be used this ramjet engine, okay. So supersonic, always remember this ramjet is what work for the supersonic, no? Supersonic engine aircraft. So this is the thing actually. So ram effect is what, it's a, it will convert high kinetic energy, that high kinetic energy into high pressure rise in the diffuser. Okay, where it will happen in diffuser. We do not have any compressor, right? So whatever the pressure rise, possible pressure rise will be there, it will be only in a diffuser. So based on this, ram effect will have a proper design of the RAMJET engine. So I will show that the special design of the diffuser, so you may understand. Okay, now see. So I'm going to draw this ideal RAMJET, and this numbering you have to follow for problems. Question in gate they are asking based on it. It's very special actually, and whenever they will ask for 2 marks, and it's very simple. Okay, so all right, now check. So this is what is spike safe here we have to put here. So because this is working for as I have given the background of it, it is working for the supersonic. Okay, so it will have a spike safe. So we can have a different type of the shock, different type of shock in the sense oblique and normal both. Okay, oblique and normal both means both shock, oblique shock and normal shock both will be achieved here anyway. But because this is the ideal RAMJET, so it is very easy for you. There will not be any formation of shock because we are talking ideal. Because if not shock will be formed, then definitely it will not be ideal. In your syllabus ideal RAMJET is given, so we are not going to discuss any shock, but this spike is what basically help to get the different shape. See here, if you check that because of this shape you will have a two types of diffuser, supersonic diffuser and subsonic diffuser. And from supersonic to subsonic, how that flow will be converted, definitely shock will be formed. Then only from supersonic to subsonic you may get. Number one. Number two, in this case we are not going to discuss any shock because you are going to talk ideal RAMJET, but in real RAMJET oblique shock will be formed. You can see here this spike we are using here. So here in this spike will get this oblique shock. See, I'm just showing this dot, but I will tell you here we are not going to discuss any shock because this is what ideal RAMJET. And definitely again it will reflect, and finally here normal shock will be formed like this. It will reflect like this. Okay, similarly here also, and this finally here will have a normal shock. So I'm just showing you, but in ideal there is no shock. Okay, so multiple shock will be there. First this will be the oblique shock, and finally this will be converted into normal shock wave. Normal shock wave. I told you in oblique, suppose this is working for supersonic, so obviously m greater than 1. After oblique shock, it is not necessary Mach will be less than 1. No, m greater than 1 means suppose Mach is what, 2. or 2.5. After oblique shock it will be 1.5. Okay, but it will always greater than 1. After oblique shock, I told you, I explained that time, after oblique shock that flow will not become subsonic after oblique shock, but after normal shock 100% flow becomes subsonic. Okay, so it is very clear, if this is oblique shock, so after oblique shock flow will be supersonic only, but Mach number will be less than previous. If it is 2.5, then after oblique shock Mach number will be 2 or 1, less than 2, but it will be less than 2.5, but it will be greater than 1 also, because flow will be supersonic only, it will not be subsonic. But after normal shock it will be 100% very clear that whatever the Mach number, it will be less than 1. So you can understand here, in this case two conditions is what happening at the same time. What is that? That supersonic flow is what reduced, but it not become subsonic. It is supersonic, but the intensity of Mach number is what reduced. Suppose earlier Mach number is what 3, then after oblique shock it becomes 2 or 1.5 or 2.5 something. Like here I have given the case, starting Mach number is what 2.5, but after oblique shock it becomes 1.5. So the intensity of Mach number or intensity of the flow, or you can say whatever the free stream Mach number, it is reduced from 2.5 to 1.5, but it is still supersonic. So but flow is what reduced, the speed of the flow is what reduced. So when flow is what going to reduce? When it is diffuser. So here you can say, in this case, this part, if I give the numbering, so this is suppose A, and this is what from here to here, you just say this point, this is what B. Okay, and this is, I can say, suppose this is C. So A to B, this A to B is the supersonic diffuser, we can say this. Okay, why I am saying supersonic? Because flow is what is still supersonic, but because Mach number is what reduced, so you can say it is diffused, hence supersonic diffuser. But what about B to C? Check in B to C, before normal shock Mach number was 1.5, but after normal shock Mach becomes less than 1. So here the flow becomes subsonic, hence it is called subsonic diffuser. So how many diffuser you are getting here? Two types of diffuser you are getting. Okay, subsonic and supersonic. So in supersonic you can see the intensity of Mach number, it was supposed 2.5, but it is reduced to 1.5. So flow is what reduced, so kinetic energy is what losing here. So that kinetic energy is what converting into pressure rise. So one pressure rise you got between A to B. All right. Second, again Mach number is what 1.5, but normal shock is what formed because of this geometry and all. So it becomes now normal shock, and after normal shock flow becomes subsonic. So again from supersonic to subsonic, that kinetic energy is what lost here, you can say, or you can say kinetic energy is what converting here into pressure rise. Obviously because of the shock losses will be there. So partial part will go to the heat generation and all, but the kinetic energy will be converting into pressure rise also at the same time. That's the reason after shock, pressure and temperature both are rising. Yes or no? That concept you already know. Normal shock and oblique shock, already you know the concept. So in both A to B and B to C, because A to B and B to C both section working as a diffuser, A to B only difference is A to B it is supersonic and B to C it is subsonic, but both are diffuser. So in diffuser what happening, that kinetic energy is what converting into pressure rise. So very huge amount of the pressure rising between A to B and B to C. Drastic, you know, after the shock formation, after the normal shock, what static temperature and static pressure, what amount is what rising? You already have solved few problems on based on normal shocks, you know that huge temperature rise and huge pressure rise, static I am saying. So this basically conversion of kinetic energy between A to B and B to C, conversion of kinetic energy into pressure rise, this effect called as a RAM effect. So because of this rise of the pressure rise and temperature rise between A to B and B to C, this will help to to raise the pressure and temperature and to support that proper combustion in combustion chamber, to proper combustion for the fuel and air. It will boost the combustion process in combustion chamber, because for the combustion very high pressure and high temperature required, then only hydrocarbons particles will burn with the air particles, right? Because the speed itself in combustion chamber is very high. But here the flow becomes subsonic after normal shock, so whatever the velocity will be there in combustion chamber, it will be the subsonic. So whatever the difference between ramjet and scramjet, in ramjet the combustion chamber velocity will be subsonic. So you can say whatever the combustion process happening, it is subsonic combustion process, okay, and subsonic flow will be there in combustion chamber. But in scramjet, in combustion chamber also supersonic flow will be there. That is the difference, rest the same, okay. But here we have not to discuss scramjet more and more, because it is not in our syllabus. Only syllabus is what? Ideal ramjet. What I have explained, so supersonic and subsonic diffuser, this is for real ramjet. This is for real ramjet, okay. So I must say this is for real ramjet, okay. But in our syllabus they have given ideal ramjet. So if you talk ideal ramjet, so there will not be any shock formation. Now I can say this, after this we have, this is the combustion chamber, okay, this is the combustion chamber, this is the combustion chamber, all right, and this is what? Nozzle, this is the exit, that's all. This thing is what happening in combustion chamber, that system will be there. There will be a, you know, that fuel injector. Here they will place fuel injector in this way. The fuel injector will be there, the fuel will be injected like this, okay, and the air is what coming like this, and there will be proper mixing of the air and fuel, okay. This is what fuel, and igniter will be there. They will make one system, that igniting system and all. So they will ignite, and this is what? Air, okay, high pressure and high temperature air, and this is the fuels in combustion chamber. That burning will start, and very high exit velocity, V exit will be very high, okay, very high velocity, and that's the reason this ramjet will have a supersonic speed, and this engine will be used for the supersonic aircraft, okay. So this is for real. Why I'm saying this is real? Because I have shown you that shock formation and all. But in your syllabus we have ideal ramjet. What till now what I have discussed, that shock formation, oblique and normal shock, it is for real. In actual this thing is what happening. But now we have to discuss the ideal ramjet, okay. So if I say ideal ramjet, so that mean of ideal ramjet or mean of ideal I have shown you. Ideal means what? See, this is explained: reversible process, reversible adiabatic process, frictionless process, isentropic process. So if I say ideal, it means isentropic process. But in actual there is no isentropic process, obviously, and that's the reason in actual shock formation will be there. But we are considering ideal, hence it is isentropic process. So we can say, okay, we do not have any shock formation. But in reality it is totally different, okay. In reality, in actual case, totally different. In actual, shock formation will be there. Why? Because there is the supersonic speed. But here I am saying it is ideal ramjet. So here I am saying it is isentropic only. If it is isentropic, then definitely we have to remove the shock, okay. Now, so we'll focus on our syllabus part only. So our syllabus, in our syllabus, ideal ramjet is given. So now I will draw ideal ramjet, and this diagram is what you have to use for your gate problems, okay. Numbering and all, everything, it is very important. So everything will be same, only the thing is I have to remove the shock formation. All right. Okay. Fine. This is the spike shape. Now we'll give the numbering. Suppose the air is what coming like this. Okay, free stream velocity we have here. Fine. Now free stream condition. Okay, let me first draw all the components, then we'll go for the numbering. Okay, so I'm considering here somewhere here we have a fuel injection. This is what fuel. They will make some system. Okay, so this is the fuel, and here we have a flame holder also, because that speed will be very high. This is the system made like this. Okay, now this is the nozzle. Nozzle. Here we can have a combustion chamber, and this whole part is what? Diffuser or inlet, right? It is diffuser, combustion chamber, nozzle. No compressor, no turbine. Okay. And this is what? Exhaust. Jet. All right. Now here we can say in this region we have a supersonic compression or supersonic diffuser, and in this zone it is called subsonic compression or diffuser, right? Obviously in nozzle what will happen, because compression is happening here, so in this nozzle expansion takes place. Earlier compression takes place in diffuser as well as in compressor, but we do not have compressor and turbine, so compression will take place in only diffuser and expansion will takes place in only nozzle. Otherwise in previous, if you remember, compression was like in diffuser and compressor, and expansion was in turbine and nozzle, but we do not have compressor and turbine, so with that part will not have. And numbering we can give here like this. This is the numbering system, because this is the free stream, so I can consider this is point A for atmospheric condition. This one I can say 1. Okay, now this is the point 2. All right, this is point 3. Between 2 and 3 nothing is there, so don't get confused. Okay, only the thing is 3 point I am showing, in the sense there is the flame holder part and all, but it is combustion chamber only. Okay, 3 is nothing actually, and this is what 4, and this 5 itself is nothing, but yes, it is the throat, so I can give the number here also. This is 5. If somewhere it is required throat, then 5 point you can take, otherwise you remove that. and this is exit. Exit you can take 6. This is the numbering. Okay, so we are not having here any kind of shock, supersonic or subsonic, nothing, because this is the ideal. So this is the diagram and this is the numbering for the ideal ramjet. Okay, so it is now clear, nothing, there should not be any kind of confusion. It's like basic only, because it is supersonic jet engine. So definitely what will be the nozzle? Nozzle will be CD nozzle, because I had explained for the supersonic flow or supersonic exit, always CD nozzle required. So CD nozzle you are having, see, this is the convergent part, this part is what? Convergent part, and this part is what? Divergent part. Yes or no? This is what? Convergent and divergent. So what type of CD nozzle we have? What type of nozzle we have? CD nozzle. Okay, there should not be any confusion. So for a ramjet engine, always CD nozzle required. Why? Because it is supersonic, right? And if it is optimum expansion, so whatever the flow it will be straight only. We do not have any under expansion or over expansion, so this flow will go straight only. It is the full expansion case. Yes or no? Right. So this is the diagram. I hope this one is clear to all. Now we'll draw the TS plot for this. Okay, now we have to draw the TS plot. And before going to TS plot, because I am considering ideal, so for the ideal condition we need to write the station values, total pressure, total temperature. Okay, if I will clear it, then we'll go for TS, then it will be very easy to you. So now check. Ideal means there is no losses. No losses in the sense there is no pressure drop. Because for the temperature, total temperature only will be changed when there is the heat addition or heat rejection, but total pressure will change because of the losses. Okay, whatever the losses doesn't matter for total temperature. Total temperature must be constant. Only total temperature will be changed when there is the heat addition or heat rejection. For the friction or for the losses, total temperature does not affect. Okay, but total pressure will change when there is the losses, when there is the friction. Here I have said it is ideal, it is reversible process, there is no loss. No loss in the sense no pressure drop. Let me mention here, no loss in the sense no pressure drop. No loss means no pressure this all information you need to remember. Okay, for ideal ramjet. Anyway, so no pressure drop in the sense what? So we'll go for the station and we'll write the value. Check. Here I have considered we do not have any shock formation, so definitely point A and point 1 will be same. So anything we can say. Now I can say 1 is a point A, because we do not have any shock formation, because if shock will come, then A and 1 will be different. Same thing I told you in turbojet also. So A and 1 will be now same, because it will be the inlet condition only, because we do not have any shock formation. Why? Because it is the ideal, number 1. So whatever the total pressure at point A, it will be P naught A. So what is the total pressure at point 1? It is P naught 1. Let me write all. P naught 2. Here it is P naught 2. Here it is obviously P naught 3. Here it is P naught 4. Here it is P naught 5. Here it is P naught 6. Sorry. Okay, so this is the total pressure. Similarly, we can write the temperature also. There should not be any confusion. So here the temperature will be T naught A. Here the temperature will be T naught 1, T naught 2, T naught 3, T naught 4, T naught 5 and T naught 6. I'm talking about total temperature and total pressure. Now see, if I am saying there is no pressure drop, it's an ideal condition. If it is ideal, then what will happen? there is no drop in pressure. If there is no drop in pressure, it means P naught A is equal to P naught 1. P naught A is equal to P naught 1. Okay. Now this P naught 1 will also be equal to P naught 2 because there is no shock formation, so this total pressure will be same. Between A to 2, total pressure must be same, P naught 2. Coming to the value of P naught 3, definitely not 2 and not 3. I told you there is no point between, nothing is there, only a flame holder is there, so hence P naught 2 is also P naught 3, and P naught 3 and P naught 4 will also be same. By because we are adding heat, so total temperature will change. Here we are adding heat. In combustion chamber, what will happen? We are adding heat, Q in. Okay, we are adding heat because here fuel is what going to burn. So obviously total temperature will change. When heat will be added, total temperature will change. Total pressure will not change. Yes, one condition when they will say there is the pressure loss, pressure drop. If they say pressure drop, so it becomes real. But what I am saying, it is ideal ramjet, so there will not be any loss. So this total pressure at station 4 also will be same. P naught 3 is equal to P naught 4, and P naught 4, and obviously station 5 is also nothing. It is only the throat only. So P naught 5, it is also same. And the total pressure at the exit will also be same because it is isentropic. So this is the condition. It is very clear. The question gate problem you will able to solve only these conditions, you know. They will give initial and entry, inlet and exit value they will give to you. But if you know how to relate both, then you can solve the problem. Otherwise it will be very difficult to you. Okay. So better, this is the thing I have, because with the diagram only I have shown you this data. Now I will give the points, okay, key points for this. So that time you need to write this value. Now check this. All right, we need to write the points. What is the point? We need to write for ideal or isentropic flow inside the engine no pressure drop, hence P naught A. Here whatever the value I have written, the important points will note down and we need to write. So important points are P naught A, then P naught 2, then P naught 4 and P naught 6. Okay, that important points. So P naught A is equal to P naught 2, you can say, then it is P naught 4 and P naught 6. Here P naught 3 and P naught 5, it is not important. Why? Because P naught 3 or T naught 3 is what? Nothing. There is flame holder only, and similarly not 5 value, it is the throat only. If something is given for the throat, then you have to use numbering for that, otherwise you leave it. But standard numbering I have given, required thing you can use. Okay, so this is the first outcome from case 1. From the case 1, this is the first outcome. Okay, you need to remember this. Now we'll go for the second, and this time we'll write temperature. Case 2. What is the case 2? Since neither work nor heat addition nor rejection takes place in the intake, many times I told you, in intake and nozzle we are not doing any work, we are not adding any heat. So the same thing here also, check in this case also. In the diffuser we do not have any work, we are not adding any heat. Okay, And same thing for the nozzle also, we do not have any work, or we do not have any addition of the heat or rejection of heat from the nozzle. So according to first law of thermodynamics, total enthalpy must be constant. If total enthalpy is what constant, then total temperature must be constant. Simple only. So I can say here neither work, okay, nor heat addition or rejection takes place in the intake or diffuser and nozzle. Hence total sorry total enthalpy or total temperature must be constant. So where total temperature must be constant, check total temperature. From here we have to start. T naught A is equal to, in diffuser we are not adding any heat, so T naught A and T naught 2 will be same, okay, point 1. But T naught 2 is the inlet of combustion and T naught 4 is the exit of combustion, so this value will not be same. Why? Because we are adding heat. But after T naught 4 there is the nozzle, so you can say T naught 4 is equal to T naught 6, because T naught A to T naught 2 is the diffuser and T naught 4 to T naught 6 is the nozzle, so this value will be same, because we are not adding any heat in this diffuser and nozzle. So I can say T naught A is equal to T naught 2 and T naught 4 is equal to T naught 6. Why it is, I have written here, so you can read this, you can understand now. Because it's a diffuser, and in diffuser we are not adding any heat. Same thing, we are not adding any heat in nozzle. So this is for nozzle and this is for diffuser. Hope this one is clear to all. Why it is? Because it is the ideal only, that's the reason this is happening for the pressure, but for the temperature everywhere it will be same. Why? Because in diffuser and nozzle, for turbojet, for turbofan, for turboprop, we are not adding any heat in diffuser, we are not adding any heat in nozzle, so total temperature must be constant, okay. And we are assuming that full expansion of the hot gases within the nozzle, it is our assumptions, okay, just like we have considered ideal. So in ideal case we are also assuming case 3. Let me write this, case 3, it's a assumption. What is the case third assumption? Full expansion of the hot gases within the nozzle, okay. So what will happen, the total pressure, exit pressure must be P6, check P6, where is the exit? Station 6 is the exit, this is the station 6 and this is also exit. So what will be the exit pressure? It will be PE, and PE is also nothing but P6, and it will be equal to PA, atmospheric pressure. That already you know, full expansion case. So for the ideal RAMJET, these three cases we have taken, case 1, 2, 3, and all three cases you need to remember to solve any problems. Okay, this is for ideal RAMJET. Now done. So three cases, three conditions. Okay, you need to remember all the time. So this will help you to solve any ideal RAMJET problem. Now in very simple way we go and we try to solve this and try to find out the relation. Okay, they are asking a very nice question from ideal RAMJET, and based on this we need to find the some conclusion. Based on that conclusion only we will get the relation between Mach number, inlet and exit. That is very important, and we will get the relation between inlet and exit velocity, because they are asking question based on that only. All right, fine. So based on the diagram, I will write the thermodynamics relation, because it is ideal RAMJET, so isentropic relation will work here. Ideal RAMJET. Okay, so for the ideal RAMJET, all isentropic relation work here. We'll write first isentropic relation. What is that? It's a total pressure and total temperature and static. So T naught A by TA. What will be T naught A by TA? Check. T naught by TA is nothing but the inlet Mach number. So this inlet Mach number is nothing but, you can say MA, or better to say M infinity. And similarly here, this is the exit velocity VE, and what is the Mach number? ME. Okay, exit Mach number. All right, now fine. So now, so see the relation. This is the inlet condition. This is what? Inlet, and this is what? Exit. Okay, so we have to write the relation, isentropic relation for inlet and exit. Inlet velocity is what I can say, it is V infinity, and exit velocity is what? VE. Inlet Mach number, because it is station A, so you can write Mach A, otherwise M infinity you can write. So this is the inlet and this is the exit. Okay, similarly you can write for the inlet, you can write a temperature as usual. T naught A I have given, and static temperature will be TA or T infinity. Okay, similarly this is the exit, so static temperature I am saying it is TE or T6, it's your choice. Okay, so that you need to take care. Now directly I am going to write the isentropic relation for inlet and exit. See here. So inlet and exit. So here this is the inlet first. Inlet. So T naught A by TA is nothing but 1 plus gamma minus 1 divided by 2 MA square. Okay, and same thing here, because T naught A is also, check what is the T naught A. In condition you check, T naught A is nothing but T naught 2 also. So the same thing you can write, because T naught A is also T naught 2, so you can write this T naught 2 by T naught A, meaning will be same. There should not be any kind of confusion. All right, this is what? Inlet. All right, now similarly you can write for the pressure also, P naught A by PA. Okay, what is the pressure? 1 plus gamma minus 1 by 2 MA square. Okay, the whole power, it is nothing but gamma upon gamma minus 1. Okay, this is the formula for the pressure. And you also know very well this P naught A, because it is the ideal ramjets. So what is the P naught A? This is the P naught A here, and this is exactly equal to P naught 6. So you can write P naught A is equal to P naught 6. P naught 6 by P A. This one you can write. Okay. All right. Now, what is the difference if I say P naught 6 by PA? Then this formula will be what? 1 plus gamma minus 1 by 2. Because this is 6 I am writing here. So this Mach number will be M6 square to whole power gamma upon gamma minus 1. Yes or no? Now, what is the difference? Just focus here. A inlet is what? Air. So this MA, obviously MA is the station, no problem. But what about gamma? Gamma for air. So you can write gamma A. Because inlet will be air. But not 6 is the exit. Yes or no? This not 6 is the exit. I can say this P naught 6, because P naught 6 by PA, or you can say PA is also PE. Check here. PA is also here. PA is also PE. So there should not be any confusion. Okay. So whatever I have written P naught 6 by PA, this is also P naught 6 by PE. There should not be any kind of confusion. So you can write this M6. Check the diagram. You can write M6 or M6. Where is the M6? At station 6. What is M6? M6 is also nothing but ME. M6 you can say, or ME. Meaning will be same. So, but exit will be what? Exit is nothing but gas. So this gamma is nothing but gas. This gamma is nothing but gas. Okay, this gamma is nothing but gas, and this is what? Air. This should be very clear here. This should be very clear. Again, if you say, I will write here neat and clean. P naught A by PA is equal to 1 plus gamma of air minus 1 divided by 2 m of station A square, okay, to whole power gamma of air divided by gamma of air minus 1. Yes or no? Okay. Now, if I say P naught A is also P naught 6, or P naught 6 is also P naught E divided by PA is also PE, is equal to 1 plus gamma, and at exit it will be gas, because fuel you have injected in combustion chamber, divided by 2, and M will be M exit square to whole power gamma of gas divided by gamma of gas minus 1. We know for ideal ramjet, what is the relation? P naught A is equal to P naught 6, and because fully expansion, so PA is equal to PE. Yes or no? Overall, we have P naught 6 by P naught E. This P naught 6 also P naught E by PE, and this is equal to P naught A by PA. If gamma air considered is equal to gamma of gas. Okay, means if we ignore we ignore the variation in fluid property, the variation fluid property, now that means R of air and R of gas, gamma of air and approximate, not exactly, approximate same, gamma of gas. If this thing is what happening, then what is the conclusion? Check, this is equation 1 and this is equation 2. If you compare this, if you say gamma of gas and gamma of air is what almost same, from the ideal ramjet you know P naught A is equal to P naught E, or you know P naught E is equal to P naught 6. Okay, or you can say P naught A is equal to P naught 6, PA is equal to PE. If everything is same, then what is the one result you will get? You will get, after comparing 1 and 2, you will get MA is equal to ME. Check by your own only. Okay, check by your own only, then it will be very clear to you. This is the very good conclusion for the ideal ramjet. This is the conclusion of ideal ramjet. They are asking question based on it. Okay, conclusion for ideal ramjet. This is for ideal ramjet. Always remember, not for real, ideal ramjet. And in your gate syllabus, ideal ramjet. So this result you need to remember. MA is equal to ME, and ME is nothing but M6. When it is possible, only one assumption you have taken, the fluid variation for air and gas, because between inlet and exit there is combustion chamber in between where you are burning fuel. So you are saying, okay, if you are burning fuel, definitely it will be gas now at exit, but you are saying air and gas value fluid properties variation is what very negligible, and if you assume it is same, then your exit Mach number will be inlet Mach number. Okay, inlet Mach number is equal to exit Mach number. Always remember, and this must be same. This is very important, very special actually. Okay, very important, very special. Fine, this is the one conclusion for ideal ramjet. Done. Now we'll go to check the relation between velocities, because they are asking velocities also, which is very important. So how to solve this? Here what I have written, this was for inlet I had started, this is for inlet, and this is for exit I had written. No? Inlet and exit both I have written, and then we combine both. Okay, this is what inlet and this is what exit, but we had combined both, and then we got the conclusion that MA is equal to M6. Done. Now what we'll do here, now we'll develop the relation between inlet and exit velocity. How to get that? We know the Mach number MA, which is also M infinity. Yes or no? MA is nothing but M infinity. What is that? It is V inlet velocity, V infinity divided by speed of sound at inlet. So inlet is what? Infinity. This is the inlet condition. Okay, what is the speed of sound at inlet? It is root of gamma of air, R of air, and T infinity, that is the inlet. T infinity is the inlet. So you can write VA because it is inlet, so root of gamma R T A, and all are air. Okay, this one. What is the exit? ME, which is nothing but M6 also. What is the ME? You can write V exit divided by A exit. What is that? V exit divided by gamma of gas, R of gas, and T exit. This one you can write V exit divided by gamma gas, R gas into T exit. And we know when MA or M infinity, both are same, is equal to ME exit Mach number, then what relation you will get? See, this is equation number 3 and this is what? 4. 1 and 2 already you have seen, right? This was the 1 and 2, 3 and 4. If you connect both 3 and 4, assuming gamma of air is equal to gamma of gas, R of air is equal to R of gas, then what result you will get? See, connect it, then you will get VA divided by gamma, I have taken common now, R into TA, which is also inlet, so it is infinity. It's your choice what you want to write. Gamma R T infinity is equal to, what is next? It is V exit of gamma R, I have taken common, it is T exit. If you write the relation, then it will be V exit is equal to V infinity, check, V exit is equal to V infinity in root. It is nothing but TE by TA or T infinity. It's your choice what you want to write. Right? This is the velocity. Okay, there should not be any confusion. This is nothing but the, you have assumed that, what assumption you had taken? You had taken gamma and R both are same, then V exit is equal to V infinity in terms of static temperature, TE and T infinity. Okay, what happened if you take temperature in terms of total temperatures? So TE, what you can write? What you can write TE? See here, T06 you had written T04, if I am not wrong, check. T06 is equal to T04. See, T06 is equal to T04. T06 is what? T0E. T0E exit total temperature. See here. So T06 is equal to T04, and similarly T02 is equal to T0A. Right? So now T06 you can write T04 now. Yes or no? So we can replace this, and because exit and inlet Mach is what same, again you can solve, you will get that. So in terms of static, this is the value. In terms of total, you will have both value. I am going to write V exit is equal to V infinity. Okay, it is nothing but TE by T infinity, it is in terms of static temperature or in terms of total temperature also, because total temperature also may be given in your exam. So you can solve this. You will get T naught 4 divided by T naught 2. This you can write. Okay. This you can write T naught E by T naught A in V infinity, or you can write V infinity. T naught E is nothing but T naught 6. You can solve, you will get. And T naught 6 also we can write T naught 4. Okay. If you do the mathematics, you will get it. So this is in terms of total temperature, exit and inlet velocity, very special. And this is in terms of static temperature. Both now formula you have. In examination, based on both, they have asked problem. Okay. If I say T naught 4, what is T naught 4? It is nozzle inlet temperature. T naught 4 is nozzle inlet temperature, and it is given case 2. T naught 4 is nothing but T naught 6, or T naught 6 is nothing but T naught E. So there should not be any confusion. Okay. So this is the sorry, this is the one second formula. I think I must say third formula. First conclusion was this one. Okay, this is the number one. You need to remember A. This is special, very special. Number two, this is B. Okay, for ideal ramjet. Number three, this is C. Ideal ramjet. One and last calculation I am going to give you. Okay, so then we'll solve the problems. Fine. Now done. One formula for the fuel air ratio and one formula for the thrust calculation. Okay, fine. So one fuel calculation will go, fuel air ratio calculation. So